The stage is yours.
Hello everyone. I'm Neil, principal engineer in Red Hat, working on oVirt storage. And I want to talk today about teaching VDSM new tricks. So first we're going to talk why oVirt needs to support 4K and what are the challenges we faced when we try to add this feature to kind of old and mature system. And we'll focus on the interesting issue of detecting block size. And finally, we'll see how we use the block size in oVirt and how we manage host supporting different kind of block size detection. And we'll see a short demo of creating a storage domain on 4K storage. So first, why 4K? Older disk used to support block size of 512 bytes. So you can write and read this size. You cannot write like 1 byte to a disk. And newer storage supports both 4K and 512. Many disks are supporting emulating 512 block size. And some newer disks are supporting only 4K and maybe cheaper and faster. Now, the main reason we need to support 4K is RHI, which is Red Hat Hyperconverged infrastructure. And what it means hyperconverged solution, hosted engine, clusterFS, and video together. And why do we want this setup? It means that you can take several cheap servers with some disk on the server, and you can combine them and create a small data center without any storage. The servers are used also for compute nodes and storage. And people like this combination. The setup is pretty complex, but to create simplicity, we need complex software behind it. So what is VDO? VDO is the new data application and compression layer in Linux. It can give you 10 times more storage with the same hardware. So it's very useful to use, and RHI wants to use VDO. Now, VDO really wants to use 4K sector size. It's designed for this. It can emulate older block size, but it's not efficient. And of course, the other reason is to support users that want to use new disks. Maybe they bought new disks and currently they could not use them. So with oVirt 438, user can use local FS storage with 4K block size and cluster FS storage with 4K block size, or with video on top of any storage. So what are the challenges? When VDSM and oVirt was created like more than 10 years ago, 4K support was not important. And trying to modify an old system is pretty bumpy ride. The first issue, trivial issue, is that oVirt storage format assumes that the block size is 512. We assume that we can access volume metadata from any host and read and write 512 bytes to some errand storage. And this does not really work on 4K storage when you can write only complete blocks, unless you have complicated locking. So this was fixed by introducing the new storage format V5. In oVirt, every storage format has a version, and we usually introduce new version when we add new features. So storage format V5 is available since 4.3.0. So everyone running oVirt 4.3 has it. And it supports any block size of the storage. It uses the same layout for any block size. So with this format, we can use 4K storage. But of course, it's not enough when we have storage format supporting everything, because we need to use SALNOC, and SALNOC cannot detect the block size on file storage. because there is no way to detect block size with file storage, or actually to get it, right? You can do some magic to detect it, but there is no official way to do it. And even if we had a way, Sunlock is not the way to the place to detect the storage block size, because VDSM, the agent that runs on every host, does need to know the block size, and it should be synchronized with Sunlock. So Sunlock is not the place to fix it. So what we did was changing the Sunlock APIs to support 4K. It means that VDSM can detect the block size and tell Sunlock what is the block size. We can see in this example that when you create a Sunlock clock space, we also specify the sector size and the alignment. The alignment is related also to the sector size. So with this, VDSM can use Sunlock with any block size. And we are ready for 4K, right? Well, no, because VDSM used hard-coded block size everywhere. Like in many places, we hard-coded the value to 512 bytes because it probably was not important thing to make it configurable at the past. So we solved it by moving to bytes. Now all VDSM APIs and the metadata that VDSM writes is using bytes. We don't store or process sector size anywhere. For example, in this internal API that used to get size in sectors, hard-coded sectors, and used to write them the same hard-coded value right to storage. Currently, we get capacity in bytes, and we saved capacity to the metadata with a new key. And this is part of storage format v5. Now, with all these changes, we are still not ready because we need to detect the block size somehow to use it. And there is no way to do it. So the way to solve this issue is to look in QEMU code. You can find a lot of interesting stuff in QEMU code. So we found that QEMU solved this issue by accessing storage. And this is what VDSM is doing now, is detecting block size by accessing storage. Now, how do we do it? We'll talk later about the details. But with this, VDSM can detect the block size. Okay. So VDSM is detecting our block size, and we can continue, and maybe we are ready. Okay, with all these changes, how do we know that we did not break VDSM? Right? We have big Python application, very little tests, because the people who wrote this code thought that tests are not very important. And when you have poor tests, for example, if I test for this room, maybe I can change something here, and then the ceiling fall down at the end of the room. So we really need good tests. So what we did was improving test coverage in storage area. When we started, test coverage was the lowest part in VDSM compared to other components. And now we have the best coverage. We added a lot of testing infrastructure. For example, we have this TMP repo that knows how to create storage domain for you. This is a real storage domain. It's not some fake and not using any mocks. This creates a real storage on your laptop or on Travis. And we run this with this user mount. This user mount you see here is another feature that will give you a mount point with several types of file system and several types of block sizes. So this test, code using this infrastructure, will run multiple times with all the combinations automatically. And we have even easier infrastructure like this user domain that will create a domain for you. And now you can create volumes and modify them and do storage operation, delete the volumes, query the metadata and everything. And of course, this test will run several times with all the configured block size and file systems. So we can tell that, for example, on XFS, this code will fail. So this was VDSM before we changed it. We took a picture before we did it. You can see that all these hard-coded block sizes and all the Rust, not the good kind of Rust that we talked about the other day. And this is now much better. I think we made a lot of progress. Maybe it's not very accurate, but we did a lot of work. So with VDSM ready, can we use 4K storage? We can create a storage domain, and then we try to provision a VM on the storage. And we found that when you install the VM, the installation fails. So after spending a lot of time with strace on QEMU, we found that QEMU is reading and writing unaligned sizes. And it turns out that QEMU does not work on certain combinations of Gluster and XFS, or XFS with local storage. And the fix was to send some patches to QEMU, and with the help of Kevin and Max, we got it merged quickly. And QEMU on RHEL 7.7 supports all these edge cases. And everyone running oVirt 4.3 has this fixed QEMU. So now we are really ready to use 4K. And then we found that, yes, we can provision a VM with 4K, we can start it, but the VM thinks that the block size is 512 and it's not 4K. So we found how to configure it using libvirt, and then we found that the VM will not boot. So it turns out that BIOS does not support 4K. And we can solve it using OVMF, which not a lot of people know about. It's not supported in 4.3 yet. Maybe it's supported in 4.4, I'm not sure. So currently, we just keep the current way that the VM thinks that this is an old 512 byte storage. So basically what we can provide now is this setup that the guests think that it's running on logical block size of 512. QEMU knows the real value, and if the guest is writing something unaligned, QEMU can fix the write. Of course, this can introduce performance issues, but we don't have yet any results, so we don't know if this is worse or better than the old way. But with this, you can use video. So how do we detect block size? Let's see how QEMU does it. This is the new way that works on Gluster in XFS. First, we read 1 byte with direct I/O, and this is expected to fail on anything unless we cannot detect the block size. So if this succeeds, QEMU knows that we cannot detect the block size. Maybe there is no block size requirement, and QEMU will fall back to a safe value that works in any case. It's not the optimal value, but it's safe. Then we try the next value, and if it succeeds, we know that this is the block size. And if not, we try the next value. And if not, this is the value. And of course, if nothing works, QEMU will fail to use direct I/O with this image. Now, there are a few issues with this. One of them is that you cannot detect the block size on unallocated block in XFS. Usually when it's remote XFS over Gluster. And this was fixed by changing QEMU image create to always allocate the first block. So when you create a new image with QEMU image create on oVirt source 3, you will get this issue fixed. So we are not affected. And of course, there's the issue of NFS. NFS does not really enforce any block size or alignment because it actually does not do any direct I/O on the server side. So in this case, QEMU fall back to a safe value. And how we do the same in VDSM, or more precisely, I process, a helper process used by VDSM. We create a temporary file, and then we do the same flow, like writing 1 byte, writing more bytes, until we find the value. As with this, we don't have any issues. We can detect any value, even with Gluster on NFS. So no issues with Gluster, no issue. Of course, with NFS, we detect the same value of 1 byte, and we fall back to a set value. So we know how we detect the block size, how we made VDSM ready. How do we use all this? So first, VDSM, or actually oVirt 438 that was released recently, supports 4K by default. So we don't need to do anything, but if you have an older version, you can use a configuration file to enable it, like we see here, or you can use it to disable this feature if it causes trouble. But generally, you don't have to do anything. When VDSM reports its capabilities, we also report the block size supported by all the storage types. So every storage type in VDSM has this supported block size list. And in this case, we can see that Gluster domain supports 512 and 4K, and also this magic auto value. And other storage types support different sizes. So we can introduce this feature gradually. What is this auto value? It is 0. You see 0 in the logs, and it means that VDSM will detect the size for you. And this is the way that we use currently. We support setting some block size, but engine will use 0 when it creates a storage domain. Now, if you request a different block size, we will validate the actual block size and make sure that it matches, because without it, storage operation will fail later. And if it failed, we have this new exception about storage domain block size mismatch. Another thing that you have to compute, alignment. In the past, alignment was always 1 megabyte. It's the alignment used by Sunlock. Now it depends on the block size, and we compute it by the number of hosts that requested by the user. The default is 250. If you use older storage with a smaller block size, we use the default value, the Sunlock default value of 2000. Generally, this is the default value used by engine, so you don't have to configure anything, but it's possible to create bigger setups with more hosts. And finally, when we have all the information, we keep it in the storage metadata. Storage metadata, this is, for example, the storage metadata for file storage. In block storage, we keep it in the VG tags. So just to recap, this is the flow. When we create a storage domain, we detect the block size. We validate the block size with the requested value in case the user asks for a specific value. We compute the alignment. We create the metadata, create the directory structure, and initialize Sunlock with all the details. So with this, you can create a 4K storage domain. But we are not done yet, because how do you manage several hosts? Well, when you can have a host that does not support 4K and a host that does support 4K. So engine has to check the host capabilities that we saw before. So when we activate a host, and we check its capabilities, and we store the value in the database. And we create a storage domain. Engine will check that all the hosts support the same block detection, and it will use automatic block detection only if all the hosts supports it. So engine will create a domain with automatic block size detection, then it will get the domain information, learn what VDSM has created, and store it in the database. So next time when you add the host to the same setup, engine can know if this host can work with this storage domain. If the host cannot work with this storage domain, it will become, you cannot activate it. Basically, all this is not needed if you run like 4.3.8 system, but we introduce this feature gradually, so it's possible that you will see these issues if you have an older version. And of course, if any host does not support the value, engine will fall back to the old way, and if you have 4K storage, it will not work. So this means that you need to upgrade your host, or maybe enable the configuration that we saw before. So let's see a short demo of creating a storage domain. Basically, all this complexity is hidden from the user. And all the details are hidden. Sorry. Okay, so we can see how we can check the host capabilities. We see the host return supported block size for several domains. We can see that the GlusterFS is supported, and this is the domain we use in this demo. So now the user just create a new domain. In the normal way, there's no configuration. You don't need to know anything about it. It just works. Of course, you need oVirt 4.3.8 or older version with enabled Gluster 4K support. So now we created the domain, and we can check what VDSM did when it created the domain. We can check that engine asked for automatic block size detection. We can see block size equals 0. It means that please detect the value. And we can see that VDSM detected the right value in the next section. This is available only in the bug log, but we can also get the domain information and look at it. So we can see that VDSM tried 1 byte and 512 and so on, and finally detected the value. So we have a Gluster domain. We can use it. We can create VMs. We can start them. And this part shows that how we can check what engine knows about this host. We see that this host supports these values, and then we can check the storage domain if engine recorded the value properly. So this is basically all. And if you want to learn more about this, you can check these links. There's an interesting RFE with many patches attached to it, because it was a huge work during the 4.3 Z-Stream development. And this is an example of VDSM test using all this infrastructure that I talked about later. And link to the user storage project, which is the helper to test with a lot of kinds of storage, a lot of kinds of block size. Please check it, and of course, oVirt.org. So any questions? Yes. Okay, so the question is if we can mix different kinds of disks in the same storage domain, and no, we don't support it. It will fail. Anything else? Nothing? Okay.
What about not?